Study about the electrolysis. So this is the second part of the lesson electrochemistry, and we studied electrochemistry is a relationship between chemical reactions and electricity. So today we are going to study the second part, electrolysis. First thing we are going to study what is electrolysis. Electrolysis, now lysis means breakdown. Okay, so for example, if you take a sodium chloride solution, you know what a sodium chloride solution is. Sodium chloride is a solid state common salt. So you dissolve it in water. When you put it into water, it dissolves, right? So therefore, it goes into Na plus ions and Cl minus ions because it's an ionic compound. Now what are we going to do? We are going to send electricity. What are we going to send? We are going to send electricity through this solution. When you send electricity through the solution, what's going to happen? You can see a chemical reaction taking place, right? So in electrolysis, what are we going to do? We are going to send a current through a chemical compound, which would result in breaking down this chemical compound. That's why we say it's electrolysis, breaking down a chemical compound using electricity. Okay, the first thing that we have to know is what is an electrolyte. Electrolyte is a solution that would allow electricity to pass through them. Okay, so we have studied under current electricity. Electricity is a flow of charges, or as we say, electricity is a flow of electrons. So we have studied about electrical conductors and electrical insulators. So under that we studied electrical conductor should consist of mobile electrons or mobile charges. So therefore, an electrolyte is a solution that allows electricity to go through them. Okay, so what is the feature which allows electricity to pass through them? It should have mobile charges, okay, which would be able to carry the electricity, right? So under the topic electricity we studied, metals are good conductors of electricity, remember? So why are metals good conductors of electricity? Because they have electrons which are able to flow. Similarly, we are going to look at the solutions which would conduct electricity, right? Now if you talk about sodium chloride, if you take sodium chloride in the solid state, sodium chloride is an ionic compound, right? So we have said ionic compounds, they have high melting points and boiling points, so therefore they would occur in the solid state. So ionic compounds, the solid states, they have charges. So I said we should have charges and they should be mobile, they have to be able to move. But in the solid state, ionic compounds do have charges, but they cannot move because they are in fixed positions. Can you understand? So since they are in fixed positions, even though ionic compounds in the solid state they have ions, they cannot conduct electricity since the ions are not mobile. Okay, right. Now what do is we take the solid. So for example, you are very familiar with sodium chloride. Sodium chloride dissolves in water. So when you put it into water, what's going to happen is it will go into ions, Na plus and Cl minus. We call this to be a aqueous solution. What do you mean by aqueous solution? When an ionic compound is being dissolved in water. So you find water molecules also there, the positive and negative ions are also there, right? Now we know, now they are free to move. So therefore aqueous solutions, when ionic compounds are dissolved in water, they can conduct electricity. Did you understand that? Ionic compounds in the solid state, they cannot conduct electricity since even though they have charges or even though they have ions, they are not mobile. But when it comes to aqueous solution, they get the ability to move, they are free to move, they have charges and they are free to move. So therefore, they are able to conduct electricity. So aqueous solution of ionic compounds are electrolytes, right? The next thing is we can heat it. If we heat it above its melting point, what's going to happen? We get sodium chloride in the liquid state. So here we get liquid sodium chloride. Now do you find water in this one? No. Therefore we can't say aqueous. This is liquid sodium chloride. Have this very well in your mind. Liquid sodium chloride. We can say fused sodium chloride, and we can say molten sodium chloride, right? So therefore, when you melt sodium chloride solid, you know what do you mean by melting, right? So melting means we are going to bring it into the liquid state. So liquid sodium chloride, it would have Na plus ions in the liquid state and Cl minus ions in the liquid state. Again, these ions are in the liquid state, therefore they are mobile. So therefore a liquid ionic compound can conduct electricity. In the ionic compounds, the liquid state, they are electrolytes, right? Now again, when it comes to aqueous solution, other than the sodium, Na plus and Cl minus, we have water also here. So the water, they can form H plus ions and OH minus ions also. So we say the sodium chloride is in the aqueous state because it is in water. This is different and this is different, right? So we are going to study what's going to happen when you send the electric current through NaCl in the fused state, and then we're going to study when you what happens when electricity is passed through NaCl in the aqueous state. Okay, right? So again I'm saying electrolyte is a liquid which can conduct electricity. So when it comes to ionic compounds do have ions, but since they are not mobile, they cannot conduct electricity. But when you heat and make it to liquid state, the ions they get the ability to move or they become mobile, so therefore they can conduct electricity in liquid state and in the aqueous solution. So other than that, we say acidic solutions or basic solutions. For examples, HCl, then let's say H2SO4 solution. Now these dissolved in water, they have H plus ion Cl minus, then these have H plus SO4 2 minus ions, so they can conduct electricity. Basic solutions like sodium hydroxide, basic solutions also, since they have ions, they can conduct electricity. Right, now how about distilled water? So for O levels, we studied distilled water, they cannot conduct electricity. So we studied there are two types of solutions that can conduct electricity and the solutions that do not conduct electricity. So solutions that conduct electricity are called as electrolytes, and the solutions that do not conduct electricity are called as non-electrolytes. Okay, so how do we identify that? Is a solution which has movable ions. For example, ionic compounds dissolved in water and ionic compounds in the liquid state or fused state can conduct electricity because they have mobile charges. But when it comes to non-electrolytes, it can be covalent compounds which can't form ions, so they can't conduct electricity. Right, now we are going to do an activity to see what are the solutions that conduct electricity. So we are going to separate. Now here they have given us 7 solutions, and now what are we going to do is we are going to check which of them are electrolytes and which of them are non-electrolytes. So I have taught you all when it comes to activity, what are we going to do? Activity, we are not going to play with something. What are we going to do? We are going to do an experiment here. So therefore we have to have an aim for the experiment, we have to have the materials, then we have to know how to do the experiment. Now after the experiment, always a scientific experiment, we have an observation. So we have to observe what is happening, and then we have to come to a conclusion, make a story with what we observed, right? So therefore we have to have an aim, we should know what are the materials that we are going to use, and then how are we going to do the experiment, and then we have to go for the observation and the conclusion, right? So in this, what are we going to do? We are going to see whether these solutions are electrolytes or non-electrolytes. So therefore the aim of the activity is to find if the solutions conduct electricity. The solutions conduct electricity, right? So therefore, I have given you uploaded the note on Google Classroom. So download that and refer the note while you are watching the video. So the aim is to see whether they are electrolytes or non-electrolytes. Okay, right. So what are we going to do is, now let's see, before we go for the materials, we go for the procedure. We'll take a beaker, and then we have to have 2 electrodes. So now we are going to study under the electrochemical cell. We studied about electrodes, but here the purpose of having an electrode is to provide electrons or provide electricity to the solution and to take away the electrons from the solution, right? Okay, let's see what's going to happen. We have electrons and then we have to have cells, batteries. Okay, we have to have cells or batteries. Then we have to have connecting wires, and then we have, this is called, they are called as inert electrodes. Now we'll be studying what are inert electrodes and what are active electrodes. Just for now, you know, this can be either platinum or else carbon. So carbon, there are, you know, there are several forms of carbon, but we can't take diamonds, therefore we can take graphite. So this is the electrolytic cell. So the electrolytic cell, we find now in a beaker, we have the solution. If it's an electrolytic cell, the solution has to be an electrolyte. So this is the activity that we do to see if the solution is an electrolyte or not, right? So therefore, this is like this is similar to a circuit that we have drawn in electricity. So therefore we have a battery here. Please concentrate on this, children. So we have a battery here, and then we have the 2 electrodes. One electrode connected to the positive terminal and the other electrode connected to the negative terminal. And then electricity would be flowing from the positive terminal to the negative terminal. So when electricity is being flown, we will see a chemical reaction taking place. But what are we going to do is, we are going to have a bulb here. Okay, on the pathway we are going to have a bulb. So therefore, what are we going to do? We want to know whether this solution is an electrolyte or not. So therefore, what are we going to do? We are going to have a bulb here. If the solution allows the electricity to go through the solution, what will happen? We can observe the bulb is glowing, right? So then we can conclude that the solution is an electrolyte. So if the bulb doesn't glow, we can conclude that the solution is not an electrolyte. So what should we do? Okay, we have to take a beaker. We have to introduce each of these solutions one at a time, and then introduce the electrodes, and then we have to fix the battery, and then we have to connect the circuit and observe whether the bulb will glow. Okay, right, so that is the procedure. And then what are the materials that we need? We need a beaker, we need the carbon electrodes, then we need connecting wires, a bulb, and the battery, right? Okay, so procedure is known, aim is known, materials are known. Next is, what are the observations? So I have drawn a table so it will be easy for you all. For each of the solutions, so therefore we would be taking coconut oil for the first time, and then what do we see? We write here, in this table, we write coconut oil. So what do we observe when you put coconut oil in this? We see that there is no glow in the bulb. If the bulb doesn't glow, that means current hasn't passed through this. So what do we observe? We observe that there is no glow in the bulb. No glow. Bulb doesn't glow. Right? So that what is the conclusion? It's a non-electrolyte. Did you understand? Okay. So now we wash the carbon electrodes, and then we wash the beaker and introduce the second solution, kerosene oil. Now kerosene oil is also a covalent compound. It doesn't have ions. So therefore what will happen? even though we have the batteries and everything connected well, there will be no glow in the bulb. So therefore second one, no glow. So it's a non-electrolyte. Water. Water actually can go into ions, but we consider distilled water is a non-electrolyte, right? Okay, so it is a covalent compound, so therefore no glow, non-electrolyte. Next one, acidic water. Acidified water, for example, we can introduce a little amount of H2SO4 and then we say it's acidified water. Acidified water would have ions. So therefore, what you observe here, the bulb will glow. So therefore, the observation is there will be a glow, the bulb glows. What is the conclusion? The solution is a electrolyte. Then we'll go to a salt solution, our solution. So we know sodium chloride dissolved in water, it has Na plus ions and Cl minus ions were there. So therefore they can conduct electricity. You can see a glow here. Therefore it's a electrolyte. Ethanol, no glow, not electrolyte. Glucose solution, glucose is a covalent compound, no ions. Therefore the bulb doesn't glow here. And the conclusion is it's a non-electrolyte. So we'll go through the electrolytic cell. So electrolytic cell, we have the beaker and then we have the electrolyte and then we have two electrodes connected to the power supply, or as we can say it's a cell. Okay, right. So in a cell we always find the positive terminal and the negative terminal. So we know electrons are flowing from the negative terminal to the positive terminal, right? Okay, so therefore in electrolytic cell, how do you identify the electrochemical cell and the electrolytic cell? In the electrolytic cell, we have the power supply outside the cell, right? So therefore, we have a power supply outside the cell that is called as the electrolytic cell. Okay, so don't confuse. Right. So this is producing electricity. There will be a flow of electrons from this terminal. Since there will be electrons coming, now in the electrolyte, we have positive charges and negative charges. Now what will happen to these positive charges? These positive charges would migrate towards the negative terminal, right? And now these positive charges, what happens to positive charges? They would accept these electrons, and then accepting electrons is, we call it to be the reduction process. So the terminal where reduction takes place is called as the cathode, right? So therefore, in the electrolytic cell, the negative terminal always acts as the cathode. Now it was the opposite way in the electrochemical cell. So if you feel like it's confusing, please refer the note before, the one I gave you before, and then come back again to this, right? So then what happens? In this side we had to produce electrons, right? Now what is the reaction that gives out electrons? Is oxidation. Remember, so we'll be looking one by one. This is just an introduction about the electrolytic cell. So the terminal which is attached to the positive terminal is called as the positive electrode. This is a negative electrode, this is the positive electrode, and this is called as the anode. Why? The negative charges gets attracted towards the positive terminal, and then these negative charges will get oxidized, releasing electrons. So therefore, electrolytic cell, these are the parts that you can see in the electrolytic cell, right? Electrolysis can be classified into two groups as electrolysis with inert electrodes and electrolysis with active electrodes. Now when it comes to inert electrodes, there are two types of inert electrodes we use, platinum and graphite. Okay, so their function is to provide electricity only. They don't take part in the reaction, they don't react. Okay, but in active electrodes, the electrodes themselves react. For example, if we take copper, then if we take silver, so metals, if we take a metal like that for electrode, it is called as an active electrode. So we will be seeing that in the next video. But today we will be completing only the first part, where using inert electrodes we can have fused electrolyte, or else we can have a aqueous solution, right? Okay. Okay, the first part of the classification is the electrolysis of molten liquids with inert electrodes. So I taught you what a molten liquid is. Molten liquid is we are not dissolving it, we heat it, so therefore the solid would turn into a liquid so that it will be able to conduct electricity. And then inert electrodes, they would not take part in the reaction. So for inert electrodes, we will be using either platinum or graphite. So the first electrolysis or electric cell we are going to study has sodium chloride in the liquid state with graphite electrodes. So we have a battery connected externally. This is a positive terminal, this is the negative terminal, right? Okay, so we know electrons are flowing from the negative terminal to the positive terminal, and current is flowing from the positive terminal to the negative terminal. Not like the previous video that we studied. In that we studied electrochemical cells. In that we had a voltmeter or an ammeter or a bulb here, but in this one we have a external power supply where power is supplied externally, making a reaction take place in the system, right? Okay, so now let's see what's going to happen. What is happening here is, see, it's sodium chloride liquid or in the molten state. Therefore we know sodium chloride at the room temperature will be in the solid state. So we would heat it and then you would melt it into sodium chloride in the liquid state. So you would have only Na plus ions and Cl minus ions in the solution. So this is the first part of our electrolytic cells, and it's going to be really easy, right? Now what's going to happen is electrons are flowing from this terminal to this terminal. So therefore, in an electrolytic cell, the negative terminal is always the cathode. Right? The electrode which is connected to the negative terminal of the power supply is going to be the cathode, right? Okay. Then the electrode connected to the positive terminal is always going to act as the anode. It's going to be really easy. I'm telling you again. The electrode connected to the negative terminal of the power supply is going to be the cathode, and the electrode connected to the positive terminal of the power supply is going to be the anode, right? Okay. So what's going to happen is, you know, electrons would flow from this side and they would be accumulated here. So therefore, Na plus ions or Na plus ion in the solution, now we have only one plus ion here. So this plus ion would get attracted towards the negative terminal or the cathode. Now we don't call it the cathode because it's a negative terminal. Actually what I wanted to say is the reduction is taking place here, but since you don't know anything about it, just understand electrons are coming from here, from the negative terminal. So we have started this electricity, and then the Na plus ions are getting, or Na plus ions are getting attracted towards the negative terminal. So what will happen? Na plus ions will go to the electrode and tell Na plus electrons, I am positively charged, I would like to accept you and go into sodium, right? Now so Na plus ion in the liquid state would go to sodium, but sodium, we know sodium is a metal, so it should be the solid state. But since the temperature here is very high, sodium won't be formed in the solid state, it will be formed in the liquid state, right? Okay. Now tell me what happened here. Na plus accepted electrons, or else they lost it. Sodium plus ions lost its positive nature. So therefore this is reduction. That's why we call it to be the cathode, right? Okay. Next one, this is the reduction half reaction. Now who would go to the positive terminal? The Cl minus ions. So you have only one minus ion here. So the only minus ion here would go into the positive terminal. So what will happen? Cl minus in the liquid state would go into Cl2 gas. Okay. So what happens here? You have two atoms, so therefore in order to balance this, you put 2 in front of this, and then you have 2 negative signs, so therefore you have to have 2 electrons. Okay. So what's happening here? 2 chloride ions would remove 2 electrons to go to Cl2 gas. So we know removing electron is oxidation, or losing its negative charge is oxidation. Removing electrons is oxidation. So this is the oxidation half reaction. We call this to be the first reaction. We'll call this to be the second reaction. But we have a problem here. We can't put them together to get the overall reaction. Why is that? Because we have 2 electrons on this side, but we have only 1 electron on this side. So therefore, what are we going to do? We are going to multiply the whole second equation by 2. So therefore, when you multiply it by 2, the whole thing you will multiply it by 2. So therefore, it will be 2 Na plus ions. Na plus ion becomes 2 Na plus ions in the liquid state. You have 1 electron. When you multiply it by 2, it's going to be 2 electrons. So you have 1 sodium atom. When you multiply it by 2, it's going to be 2 sodium in the liquid state. This was the second equation. When you multiply it, it's going to be the third equation. Now we have no problem. We have 2 electrons on this side and 2 electrons on the right side and 2 electrons on the left side of the equation. So you will put together first equation and the third equation when you put them together. So how do you put them together? We take this part, 2Cl minus liquid plus this part, 2 Na plus in the liquid state plus 2 electrons would go to, then you go to the right side of both the equations, Cl2 gas plus 2 electrons, and the right side of this equation plus 2 Na liquid. Now what will happen? You can cancel off the 2 electrons on the either sides and then write 2Cl minus in the liquid state, 2 Na plus in the liquid state will go into Cl2 gas plus 2 Na liquid. Right, now what's going to happen? So this is given in the note. So you go through it again and try to understand, right? Okay, so I'm telling you again what is the first type of electrolysis we're going to study. Electrolysis of a molten liquid with inert electrodes. What do you mean by inert electrodes? The electrodes doesn't react. They only supply electricity to the electrolyte, right? Okay, so you can use either graphite or platinum electrodes, right? So the first one we're going to study is electrolysis of molten sodium chloride. So molten means you have heated sodium chloride. So in the solution, in the liquid, we find only Na plus ions and Cl minus ions, right? So we have graphite electrodes connected to the power supply, right? So the electrode connected to the positive terminal is called as the anode, and the electrode connected to the negative terminal is called as the cathode, right? So electrons would start to flow from the negative terminal to the positive terminal. So let's see what's going to happen. When electrons comes towards this electrode, the Na plus ions, they are positively charged, therefore they would get attracted towards the electrode, and the positive ions would accept electrons and go to Na liquid. Okay, since in this reaction the Na plus ions accepts electrons, this is called as reduction, and this is a reduction half reaction. In this one, what happens, the positive terminal is the negative ions would get migrated towards the positive terminal, and then they would get oxidized. So how will Cl minus get oxidized? Cl minus will remove 2 electrons and go to Cl2 gas, right? So therefore, we see 2 problems with this equation. Now we can't put them together because we have 2 electrons on this side, but we have only 1 electron. So we are going to multiply the whole thing by 2. You have 1 Na plus ion. When you multiply it by 2, it becomes 2 Na plus ions. We have 1 electron. When you multiply it by 2, it's going to be 2 electrons. We have 1 sodium in the liquid state. When you go to multiply it, it would be 2 sodium in the liquid state. So then what will happen? Okay, then we see we have 2 electrons here and 2 electrons here. We can add them up. So therefore, we will put together one first reaction, the second reaction. It will result in, so when you are putting the reactions together, what do? We have to add the left side of this reaction and the left side of these reactions together, and the right side of this reaction and the right side of this reaction together on this side. Okay, so we have 2 Cl minus ions, 2 Na plus ions and 2 electrons on this side, and this part Cl2 gas and 2 electrons plus the 2 Na liquid, right? Then what do? We cancel off the 2 electrons on the other side, and then we get the overall reaction. So what has happened? The Cl minus and the Na plus ions has gone into Cl2 gas and sodium liquid. So what do you observe in these electrodes? In the positive terminal, you can see a colorless gas given off, and then in the negative terminal, we can't say a solid is being deposited while sodium is formed in the liquid state, right? Second example for electrolysis of molten liquids with inert electrodes. We are still in the first part of our classification, but it's another example for molten liquids with inert electrodes. So what are the inert electrodes we can use? We can either use platinum or graphite, right? Okay, so what do you have in the electrolyte? We have magnesium chloride in the liquid state. So what do you find in the magnesium chloride liquid state? We can find Mg now 2 plus, Mg2 plus in the liquid state and Cl minus in the liquid state, right? Okay, so what will happen? Positive ions would get migrated towards the negative terminal, and the negative ions would get migrated towards the positive terminal. Now I haven't given you this in the note. What you have to do is, you have to look at the note for sodium chloride and then listen to the video, and then you have to start writing alone, and then you have to take pictures of what you have written and send it to me, so I would know whether you understood it or not, right? So what's going to happen is, the positive ions would get migrated towards the negative terminal, and the negative ions would get migrated towards the positive terminal. So let's see what's going to happen at the negative terminal first, right? So the Mg2 plus ions, so we know electrons are flowing from the negative terminal to the positive terminal, so the electrons that come to the edge of this electrode will be given to whom? Mg2 plus ions. So Mg2 plus ions will go to the negative terminal, and Mg2 plus ions, similar to the Na plus ions, the previous one, Mg2 plus ions would say, okay, they are in the liquid state, they would say, I would accept 2 electrons and go into magnesium in the liquid state. Why in the liquid state? Even though magnesium is solid at room temperature, we can't have magnesium chloride in the liquid state at room temperature. That means we are maintaining high temperature in the sample or in the electrolyte, electrolytic cells. Therefore, magnesium that is being formed at the electrode would be also in the liquid state, right? Okay. So what type of reaction is this? This is accepting electrons, taking in electrons to go to magnesium. So that is called as reduction. So this is the reduction half reaction. This process is reduction. So the terminal or the electrode where reduction takes place is called as the cathode. Right, now let's see what's going to happen here. Who would get attracted towards the positive terminal? The negative ion gets attracted towards the positive. The negative ion gets attracted towards the positive terminal. So let's see what happens. Cl minus. So the same thing that happened. Cl minus in the liquid state. They have to remove the electrons, no? They have to remove the electrons and go to Cl2 gas. This is a bit, you have a problem here. What? You have 2 atoms here, so therefore you have to put 2 in front of this. And since you have 2 negative ions here, you have to, in order to balance it, you have to have 2 electrons here. So this means 2 Cl minus ions will remove 2 electrons to go to Cl2 gas. And then, okay, what happened here? The chloride ions or Cl minus ions removed electrons. So that is called as removing electrons or getting rid of electrons is called as oxidation. Where does oxidation takes place? Oxidation takes place at the anode. So therefore this terminal, the positive terminal, is called as the anode. Right? Okay. So we have the oxidation half reaction, then we have the reduction half reaction. We call this to be the first equation. This is the second equation. We have no problem on the both sides. We have 2 electrons, so therefore we can put the first equation and second equation together, writing 2 Cl minus in the liquid state plus this part, Mg2 plus in the liquid state plus 2 electrons. Then what is on the right of each equation? So this Cl2 gas plus 2 electrons plus Mg in the liquid state. So you can cancel out the electrons on the either sides. This would result in 2 Cl minus ions in the liquid reacting with Mg2 plus in the liquid state would form Cl2 gas plus Mg in the liquid. So this is going to be the overall reaction. So what happened here? MgCl that was there in the liquid state would go into Cl2 and Mg. So what do you observe? You can see, where do you find Cl2? Cl2, so you have to say In positive terminal, what is the reaction taking place? If it's oxidation, this is oxidation half reaction. The electrode where oxidation takes place is called as the anode, and then negative terminal is where reduction takes place, and it is the cathode. And then you have to write the reduction half reaction, and then you have to put the oxidation half reaction, reduction half reaction together to get the overall reaction. And then you have to say what do you observe. You won't see Mg2 plus ions, Cl minus ions, or the electrons flow. What you can see is, you can see a chlorine gas or colorless gas is chlorine is not colorless. Chlorine gas is being produced at the positive terminal. Okay, chlorine is not colorless, and then magnesium is being formed here, right? Okay. So the next thing is, you have to try to draw for potassium chloride and calcium chloride. So you have to do that alone, and then you have to take a picture of the work that you have done, and then you have to send it back. So I would be doing the videos on Tuesdays and Thursdays and Saturdays. So this week we will be continuing with electrochemistry, and then from next week we will be starting the life processes of the body. So you have to start doing your work now, because I did not get the the worksheets of everyone, but please make sure that you complete your work and send it to me, so I know that you are following what I have given.